Okay, so remind me a couple things about rhombuses that we talked about. So, good morning, Miguel. All right, so how is a rhombus different from a square? You don't know that the angles are what? Yeah, all the angles in the square are 90, are equal to each other, but in a rhombus, that's not necessarily true. So number 3, even though it's not slanted, how come number 3 is still a rhombus? Because all the sides are congruent, and it doesn't tell you anything about the angles. So we said before, you can't assume. However, as long as it's a rhombus, you know that the consecutive angles, so the ones that are next to each other, have to be what? They have to be supplementary, they add up to 180. Good. Okay. All right, so we're going to talk about the conditions for these special parallelograms. Just as like preparing, your test on Chapter 6 is going to be on Friday, so all your homework for Chapter 6 is due Friday. This is a pretty short chapter, so I know you guys just had a quiz, but there's only 2 more lessons, so the Chapter 6 test is going to be on Friday. It's going to be the second half of your class on Friday. We'll do a review during the first half. All right, I haven't decided yet if it's going to be Kahoot or like at your boards. What would you guys prefer? You'd rather do a Kahoot? Okay. All right, so we'll do a Kahoot during the first half on Friday, and then in the second half of class, you guys will have your test. So make sure that you're staying on top of your homework. If you have not done your homework, you have 6 lessons to get done, 6-1 through 6-6, okay? All right, so we're going to talk about a bunch more theorems today. Again, focus not on the numbers, but just the ideas behind the theorems. I don't really care if you can name the numbers as long as you can describe in a 2-column proof what you're talking about. So conditions for rectangles, which is if a parallelogram is a rectangle, these things have to be true. So if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. How do you know that? Why does that have to be true? If one angle of a parallelogram is 90 degrees, how come all the other ones, how come it has to be a rectangle? Not quite, because you don't have inside-outside angles. What do we know about the angles in a parallelogram?
The opposite sides are equal. No. Oh, yeah.
The opposite angles are, okay, so if this is 90, what does this have to be? Okay, all right. Consecutive angles have to be 180, so if this is 90, then 180 minus 90 is 90, so then that one has to be 90, and if this one is 90, that one's 90. All right, so if it's a parallelogram and one of the angles is 90, it has to be a rectangle, because if one of them is 90, all the rest of them have to be 90. All right, how come you don't know that it's a square? You don't know anything about the sides yet. Okay, so that's just a rectangle. Are all squares rectangles? Yes. Are all rectangles squares? No. Okay, good. All right. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if the diagonals are congruent, that means it's a rectangle. Okay? Because if they were not congruent, then they wouldn't be what? They wouldn't be what? A rectangle, yeah. Because they don't bisect each other they're not all equal to each other. Okay, so if the diagonals are congruent, then that means that this has to be a rectangle. So if I give you this shape right here, is that a rectangle? Yeah or no? Yes? Okay, how come? The diagonals are equal to each other. This one is 2 congruent pieces, and this one is 2 congruent pieces, so they would be the same. So yes, this is a rectangle. All right? Okay. These are the conditions for rhombuses. So again, these are the 3 special things that we learned about rhombuses, kind of going backwards. So if a parallelogram is a rhombus, then these 3 things have to be true. So if one pair of consecutive sides is congruent, then the parallelogram is a rhombus. Why is this true? They all have to be congruent. And you know if FE is this, what's GH? The same thing. And if EH is this, what's FG? The same thing. So those will all be congruent. So even if you only know two of them, if they're the two consecutive sides, then that's enough to say that they're congruent. Is it enough to say this? Do you know that this is a rhombus? No. Why not? You don't know anything about the consecutive sides. What do you know this is? You know it's a parallelogram. What would you need to know it's a rectangle? You need either the other sides or you would need at least one of the angles. Good. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So again, if these make 90-degree angles, then it has to be a rhombus. And then if one diagonal of a parallelogram bisects the pair of opposite angles, then the parallelogram is a rhombus. So remember that the diagonal cuts those angles into two equal pieces if it is a rhombus. Okay, so those are all the 5 things that we talked about on Thursday. It's just kind of flipping it. So if you know those things are true, then it has to be a rhombus. So if I don't tell you it's a rhombus, if I just tell you it's a parallelogram, this is how you could prove backwards that it's a rhombus. All right, so how can we use this? So let's take a look at this 2-column proof. How do I start? Draw the chart. What's my first given? All right, if I write it, what should I do with my picture? I should also draw it or mark it. So AB is congruent to CD. What else? BC is congruent to AD. BC is congruent to AD. AD is perpendicular to DC, and AC is perpendicular to BD. So what does that mean? If AD is perpendicular to DC, where? Between AD and DC. So AD and DC means this angle right here is 90 degrees. Perfect. And same thing with AC, BD, right? So AC, BD. So where would that 90-degree angle be? Middle, like somewhere in the middle with the diagonals. And if this is 90, what does this have to be? And if this is 90, what does this have to be? And what about this? All right, so again, if one of them is 90, then you know what? All of them are 90. So I want to prove that it's a square. So if I want to prove it's a square, I know right now that all 4 of the angles are what? They all have to be 90. What else do I need to prove that it's a square? I need to prove that the sides are equal, right? How could I do that? Because right now I know that the opposite sides are equal. How could I prove that AB is like equal to AD? What do you think?
We are going to do sine, no.
Maybe? I don't know. Do you guys have any ideas?
Like CDA would be side equals side. I don't know.
CDA, so you're talking about like this triangle down here?
Yes.
Okay. But you'd be proving that it's congruent to what, this one up here? Does that help you prove that the two sides are congruent?
No.
No? Well, I know, one thing that I know for sure is if angle D is 90 degrees, what can you say about ABC? Angle A, B, and C are 90. How do you know that? Opposite angles, and so opposite angles are congruent, and consecutive angles have to be what? Okay, so I just need to prove that these two are congruent. How can I do that? If I know that this is 90, if I know this is 90, think about it like, look at CBA, that triangle Charlize was talking about. Do I know anything about this angle and this angle? They're half of what?
90.
Why?
Because they bisect the diagonals, bisect
The diagonals bisect the angles. So if these two angles are equal, what do you know about the sides? The sides are equal because that makes it a what kind of triangle? Mm-hmm. Okay, so what angle is this right here? BAC. So angle BAC has to be equal to angle what? BCA, because they both must be what? If these angles are 90, what do these two have to be? 45. So they must be equal to 45. Because the diagonals do what? Bisect. All right, and if those are both 45, then it means that BA and BC have to be what? Congruent to BC. Because of isosceles triangles. And then we can say that it's a what kind of shape?
Square.
Good. ABCD is a square. All right, all four sides are equal and 4 90-degree angles. They are. Okay, so go try this one.
On our chairs?
If you want to do it at your seats, you can. If you want to do it at the boards, you can. Okay, this doesn't tell you it's a parallelogram. So can you start making any conclusions here? No, so then you would say what? So it says determine if the conclusion is valid, which you just said it's not. If not, tell what additional information is needed. So what would you need to know? You would need to know ABCD is a parallelogram, because if that were a parallelogram, then you could say that since this is AB, the opposite side is also congruent, and then you could say that this side is congruent, and then you could say it's a rhombus. But if you don't know it's a parallelogram, you can't make any conclusions. So is there a way to do a 2-column proof here? No. So that's a pretty short one. All right? Okay, so at your boards, I want you to try these. There's a lot of words up here. You're basically just filling in the blanks based on those conditions. What shapes are these going to be? Some of them are shapes. Some of them are other words. Down here, you're completing this exercise using this given and this conclusion if they give you the information in each of these questions. Go ahead and try those.
Oh, okay.
Okay.
Good afternoon, Vernon.
Good afternoon. It was quite good. All right, so how would I use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square? So how do I know? Tell me about the diagonals. I know it's a parallelogram if they bisect each other, right? But I know it's a rectangle if they are congruent. So to prove it's a rectangle, I would need them to be congruent. If it's a rhombus, what do they do? Perpendicular and bisect each other. So it's perpendicular and they bisect each other. So just looking at this, I know we can't assume, but what do you think that's going to be? It's probably going to be a rhombus. I can start by using the diagonals. How can I prove that they are perpendicular to each other? Use the rise, find the slope, and if they're perpendicular, the slope should be what? Negative and flipped. Good. So the slope of BD would be what? You go down how many? So the slope of BD is negative 4 over 2. Good. Negative 4 over 2. What does that reduce to? Negative 2 or negative 2 over 1. All right. And then the slope of AC, how many up do you go? Up 4. And then you go over 1, 2, 3, 8. Okay, so I go over 8, which reduces to 1/2. So are those opposite reciprocals? Yes, so they're perpendicular. So now I just need to prove that they bisect each other. How would I do that? Distance formula? Okay, so the distance formula of what though? Yeah, if I want to prove that they bisect each other, I need to prove that, give me a letter. X. All right, I need to prove AX is equal to what? XC, and I need to prove BX is equal to XD. That's a lot of distance formulas. I don't want you all to do all 4. So this row right here, I want you to do BX. So use the distance formula to do BX. First, let's figure out this coordinate. What's this coordinate? 4. 4. Okay. This row, you guys are going to do AX. All right? This row, 1, you guys are going to do XCX. And this row, you guys are going to do XD.
On a test, are we actually going to have to do all 4 of them?
Probably not. All right, do XD. You guys are doing CX. 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 Distance formula is... All right, does anybody have BX? BX? Square root of 5. Good. Square root of 5. All right, did somebody get DX? DX? I give DX. Maybe I give that to no one. All right, what about AX? AX, guys. You're not in that row, so I know you can do it. Which row had AX? How? Should be 4 minus 2, right? Yeah, which is 2. And 2 squared is?
4.
And then 4 minus 0 is?
4.
So 4 squared is 16. So square root of 20. Good. So AX is square root of 20. Okay, CX? Good. Square root of 20. So are those equal? Okay, that's good. And then what about DX? Square root of 5. Good. So is that a perpendicular bisector? Yes. So Daisy asked, will I ever have to do this on a test all by myself? Probably what I would give you on a test is I would say, like, BX is a square root of 5. Prove that this is a rhombus. So you just have to find, like, that one piece. Okay. All right. What does this appear to be? A rectangle. So again, it might not be, but if it's a rectangle, what would the diagonals be? So we need to do what? Distance formula for which ones? FH and GE. All right, what would FH be?
Negative 3 minus 2.
All right, what's negative 3 minus 2? Negative 5. Negative 5 squared is? All right, and then 2 minus negative 3 is? 5. 5 squared is? All right, and then what about GE?
3 minus 4, 3 plus 4. And 0 minus 1.
All right, 3 minus negative 4 is 7 squared plus,
1.
which equals what? 49 plus 1 is good. So is it a rectangle or a rhombus? Good. Okay. All right. How can I tell if it's a rectangle or a square? If the sides are equal. So you would need to figure out the length of these. Does that appear like it's going to be a square? No. Can you assume that? No. Since it's on a coordinate plane, can you do a little more assuming? Yes, because a coordinate plane is basically like putting a ruler next to it, right? So you can kind of prove that those are not the same distance. If you really had to do it, you do the distance formula for opposite sides. Okay. All right, go ahead on your exit ticket templates. If you did not get one, come grab one, but do the exit ticket numbers 2 and 3A and B.